So dear students, let us start this very interesting and important chapter that is called structure of atom. Structure of atom. So students, we have already studied few things about atom in previous chapters. Let us recall few of those things. Atoms are very small in size. We have already seen that. Atoms are very small in size. They are so small in size, students, that we cannot see them by our naked eyes. They are very small. Right, students? Then everything is made up of atoms. Everything around us is made up of atoms, students. These huge mountains which you see, they are made up of small atoms, tiny atoms. The pen, pencil, eraser, whatever you use in your geometry box, they are all made of atoms. Wall, bricks, table, chair, they are all made up of small atoms, students. Even our body is made up of small atoms, students. The computer which you are seeing in front of you, they are also made up of small atoms, students. Everything on this earth, everything around us is made up of small atoms, students, right? Then atoms are indivisible. They are very small. They cannot be further divided, right? They are the smallest possible particles that we can think of, students, right? So if you divide any substance and if you keep dividing it forever, finally you will get atoms. But atoms cannot be further divided. They are the smallest possible particles, and that's why they are said to be indivisible, isn't it? So students, discovery of atoms was a very important incident in the history of science. And in fact, scientists all around the world were very excited with this discovery. So now scientists started to conduct a lot of experiments on this atom, because they wanted to understand the properties of atom in great detail, the behavior of atom in great detail. You understand? So scientists worldwide started doing a lot of experiments on atoms, students. Now, in some of the experiments, they found something like this. Say this is an atom. It is very small in size, students. It is very small in size. In some of the experiments, it was found that some very small particles, were coming out of the atom. You understand? In some of the experiments, scientists found that some very small particles were coming out of atoms, students. And these small particles were called subatomic particles. Subatomic particles. So students, I can write down here that subatomic particles are small particles inside atom. Now students, this was a very important point. What it meant was that inside atom there are small particles, right? Inside atom there must be small particles. That's why these small particles are coming out of atoms in some experiments. You understand, students? That small particles are present inside atom, and they were called subatomic particles. Now this was an important point. Why, students? Because let us recall what Dalton told. Dalton had told that atoms are indivisible. Right, students? We saw this in previous chapters, that Dalton told that atoms are indivisible. He said that atoms are the smallest possible particles. They cannot be divided further into smaller particles. Now this thing was proved wrong. Why? Because now we came to know that inside atoms there are small subatomic particles. So now it was established that atoms are not indivisible. Okay, students, this is an important point, students. Some of the students get confused here, because in some of the chapters they study that atoms are indivisible, but later on in this chapter we study that atoms are not indivisible. So initially Dalton told to the entire world that atoms are indivisible. They are the smallest possible particles, and people even believed this. But later on, when such things happened in different experiments, people understood that okay, Dalton was wrong. Atoms are actually divisible. They are smaller particles inside atoms. Fine. Now students, please try to understand one more important point here, that atom looks very small, But it seems that inside atom there are a lot of things. So there is an entire world inside the atom itself. There are a lot of particles inside atoms. They are arranged in a particular manner inside the atom. So in this chapter, that is what we are going to study. That what is there inside the atom? What is there inside the atom? What particles are there inside the atom? How they are arranged inside the atom. Right, students? So that is the topic of study in this chapter. So students, let us start this chapter with full force and full enthusiasm. Okay? So now, charged particles in matter. So see students, we have just seen that inside an atom, there are small subatomic particles, right? Now these subatomic particles are of three types. They are of three types. What are these three types, students? So the first type is electron. Second is proton. And third is neutron. Okay, students, so you must remember these names with their correct spelling. It's very important, students. So inside atoms, there are subatomic particles. They are very small particles, and there are three types of particles. One is electron, another is proton, and third is neutron. And as you can understand, they are very small, students. So first of all, let us talk about their mass. Let us talk about their mass. That what is their mass? Obviously, you can understand that they are very small in size, so their mass must be very small as well. So you can see that mass of an electron is 9 into 10 to the power minus 28 gram. So this is mass of an electron, mass of one electron. And you can see, students, it is very small because 10 to the power minus 28 gram. So it is very small. Mass of proton is 1.6 into 10 to the power minus 24 gram. This is also very small if you see, students. But clearly you can understand that mass of proton is higher than the mass of electron, isn't it? This mass is higher than this mass, right? Then mass of neutron is 1.6 into 10 to the power minus 24 gram, right, students? So clearly you can see some of the points here. The first point which you must be able to notice here is that mass of proton and neutron are same. They are having same mass. So mass of proton and neutron is almost same. Right, students? Now you must be thinking that why I'm using the word almost here. See, the mass which I have told you here, this is not the exact mass. This is approximate mass of proton and neutron, and approximately their masses are same, students. If we do very exact analysis, their mass is slightly different, but that is beyond the scope of this syllabus. Okay. So first thing is mass of proton and neutron is almost same, students. Now next important point is, look at the mass of electron. So mass of electron is clearly smaller than these two masses, right? So we can write that mass of electron is smaller than that of proton and neutron. Okay, students, you can clearly understand this. Now let us do one thing here, students. Let us take this ratio of mass of proton divided by mass of electron. Okay, let us find out this ratio, students. So see, mass of proton, that is 1.6 into 10 to the power minus 24. Mass of electron, that is 9 into 10 to the power minus 28. So if we calculate this, we'll get 1777.77. You can calculate it, you'll get this. This is a complicated number, so we can round it off to around 2000. We can write that this is very close to 2000. So students, what it means that mass of proton is approximately 2000 times more than the mass of electron, isn't it, students? Mass of proton is approximately 2000 times more than the mass of electron. So I can actually write that mass of proton is around approximately 2000 times of mass of electron. So students, you can see here that mass of proton is actually much more than mass of electron. So sometimes it is said that mass of electron is negligible compared to mass of proton and neutron, right, students? See, first of all, you also need to understand that here I have taken mass of proton divided by mass of electron, and the ratio has come out to be this. But if I would have taken mass of neutron divided by mass of electron, then also the ratio would have been the same, students, right? So because mass of proton and neutron is much higher than the mass of electron, we say that mass of electron is negligible compared to mass of proton and neutron. Let me give you an example to explain you better. Look at this photograph, students. What do you see? This is an elephant and this is an ant, right, students? Now, see, mass of ant is much smaller compared to the mass of elephant, isn't it, students? So we can say that the mass of ant is negligible. Right, students? So in a similar manner, because mass of electron is much smaller than mass of proton, so we are saying that mass of electron is negligible. You understand? Right. Now, one more thing, students, here, that see, this mass of proton, which is 1.6 into 10 to the minus 24 gram, and you should remember this, is also sometimes said to be 1 U or 1 AMU. Right, students? We have seen this in previous chapters, that mass of proton is also said to be 1 U or 1 AMU. So basically, if you write 1 U, it is same as writing 1 AMU. U or AMU, they are unit of mass. They are unit of mass, right? As gram is a unit of mass, U or AMU, they are also unit of mass, and this, in this unit, mass of proton is 1. So you can understand that mass of neutron will also be written as 1 U or 1 AMU. What about the mass of electron? As we have already seen that it is negligible. It is negligible. Fine. So I hope, students, all these things are clear to you, and you must remember all these things. These are important things from exam point of view. So now let us move ahead. So we have talked about mass of these subatomic particles. Now let us talk about charge of these subatomic particles. So see, students, this electron, this small subatomic particle inside the atom has negative charge on it. Students, negative charge on it. This proton has positive charge on it. And what about this neutron, students? This neutron has no charge on it. You understand, students? So now the question is, how much negative charge is there on this electron? So the negative charge on this electron is minus 1.6 into 10 to the power minus 19 coulomb. Coulomb is unit of charge, students. You must be knowing by now. So negative charge on an electron is minus 1.6 into 10 to the minus 19 coulomb. Negative on positive charge on a proton is plus 1.6 into 10 to the minus 19 coulomb. And obviously there is no charge on neutron, students. So you can see a very important point here, students, that electron and proton have same charge. They have same charge. The value of charge on both of them is same. However, electron has negative charge and proton has positive charge, but the value is same. So we can write this down, students, that electron and proton have same amount of charge. Okay, but the sign is opposite. Students, sometimes we also write that this electron has minus 1 charge, and this proton, basically this proton, has plus 1 charge, right? Sometimes, for simplicity, we just write that electron has minus 1 charge and proton has plus 1 charge, right? So this whole quantity 1.6 into 10 to the minus 19, that is being represented by 1 here. Okay, students. Once again here, 1.6 into 10 to the minus 19, that is being represented by 1 here. Understood? One more interesting point here. See, this electron is represented by a small symbol. And the symbol of electron is E minus. Why E minus? E for electron, and this minus represents that electron carries negative charge. Okay, students. Now, similarly, you can think about the symbol of proton. What must be the symbol of proton, students? Can you guess? P for proton, and on the top of it will make plus. Plus represents that proton carries positive charge. Then, following the same logic, what should be the symbol of neutron, students? That is simply N, and nothing on the top of it, because it has no charge, students. So I hope this concept of charge is also clear to you. So you can see that these three subatomic particles, electron, proton and neutron, they have different masses, they have different charges, and we must remember all of this. So let us do this very small question here, students. Find the net charge on an atom in the following cases. So let me explain you the question. See, in this case, this is an atom, and inside this atom we have this subatomic particle electron and one proton, students, right? So we have to tell that what is the net charge, inside this atom. What is the net charge inside this atom, students? So see, this has one electron and it has one proton, students. So because it has one electron, so there is -1 charge. Okay, students. Now because it has one proton, so due to that it will have +1 charge, right, students? So the total charge inside this atom is how much, students? Obviously it is 0. So that is our answer, students, that the total charge inside this atom is 0. Now we have to do the same thing here, students. So inside this atom, this second atom, we have 2 electrons, 2 protons and 1 neutron. So we have to tell what is the total charge inside this atom. So students, we have 2 electrons, students. So due to this we will have -2 charge, right? If we had 1 electron, we would have -1 charge as we had here. But here we have 2 electrons, so we will have -2 charge. Similarly, we have 2 protons, students, so we will have +2 charge. And on the top of this, we have 1 neutron, students, 1 neutron. So due to the neutron, how much charge we'll have? We'll have no charge because neutron has no charge. So if we sum all of them, once again we have 0 charge. So we can say, students, that inside the atom, the net charge is 0. Net charge is 0 once again inside this atom. Now let us do this question, students. So here in this atom, there are 2 electrons inside this atom, 3 protons and 2 neutrons. So because of these 2 electrons, there will be -2 charge. Because of these 3 protons, there will be +3 charge, and because of these 2 neutrons, there will be 0 charge. So if we sum all of them, we will be left with +1 charge, students. So that is our answer, that inside this atom there is +1 charge. You understand? Very simple, students, very simple. So this is a very simple question. Now here I can ask you one more question, students. So here the question was that find net charge on all these atoms. Find net charge on all these atoms. Let me ask you now, find the net mass of all these atoms. Find the net mass of all these atoms. So let us do that, students. So see, here we have 1 proton. So due to this 1 proton, we will have mass of 1 U, right, students? Now electron is also there, but as we have seen that mass of electron is negligible. So we will not consider its mass, right? So the total mass inside this atom is simply 1 U, students, 1 U. Understood? Now look at this, students. So here we have 2 electrons. Once again, if we are talking about mass, then if we have 2 electrons, we'll consider their mass to be negligible. Okay, students? We have 2 protons. So due to these 2 protons, we will have 2 U mass, 1 for each. We have 1 neutron, students. So you must remember that neutrons also have mass, same as protons. So 1 U for this 1 neutron. So total we have 3 U mass, students, 3 U mass. So that is the answer, that for this atom, the total mass is 3 U. Understood? Similarly, you can do this last one, students, very simply, that 2 electrons are there. So due to these electrons, we'll have negligible mass. We have 3 protons. So due to these 3 protons, we'll have 3 U mass. We have 2 neutrons. So due to this, we'll have 2 U mass. So total of this, we have 5 U mass. That is the answer, students. You understood? So now, discovery of subatomic particles. So students, how these subatomic particles, electrons, protons and neutrons were discovered. How scientists came to know about them. So first of all, let us talk about electron, students. So students, electron was discovered by great scientist J.J. Thomson in 1897, students. J.J. Thomson. He was a great scientist, students, and he also won Nobel Prize in 1960 for discovering electron. Students, I must tell you that J.J. Thomson was really a great scientist, and not only he won Nobel Prize, but many of his students also won Nobel Prize. See, students, any great or big scientist will have a lot of students, and those students are also called assistants. They are also called assistants of the scientist. They actually helped the scientist in his research work and various other things. So, he was such a great scientist that he definitely won Nobel Prize, but many of his assistants and students also ended up becoming very big scientists in their career and won Nobel Prizes. So anyways, now let us see how J.J. Thomson discovered electron. So look at this setup, students. This apparatus, this is called discharge tube. Discharge tube, or also this is called gas discharge tube. So J.J. Thomson made a setup like this and did some experiments here. Please note that this plate, which is connected to the negative terminal of the battery, is called cathode, and this plate, it is made of metal. This plate is also made up of metal. So this plate connected to positive terminal of the battery is called anode. So students, you should remember these names, cathode and anode. Okay. And this box is made up of glass. So it is transparent and anything which is going on inside can be seen. So in certain situations, in certain circumstances, J.J. Thomson noticed that some small particles were coming out from cathode. Some small particles were coming out from cathode. And also these small particles were negatively charged. You understand? So J.J. Thomson did a lot of experiments with this gas discharge tube, and in certain situations he noticed that from cathode small negatively charged particles were coming out. These stream of particles were called cathode rays. Cathode rays. So we can write this down, students. Stream of small negatively charged particles coming out of cathode were called cathode rays. Cathode rays. Right, students? And these small particles were named electron by J.J. Thomson. These small negative particles were called electrons. So you understand briefly how J.J. Thomson discovered electrons. Right? We are not going to go in great detail of this experiment. You should just understand that he made a setup like this, which is called gas discharge tube, and he noticed that from cathode small negatively charged particles were coming out, and these stream of particles were called cathode rays, and these small particles were called electrons. So now students, let us talk about proton. How proton was discovered. So students, look at this scientist, great scientist 𝐒𝐔𝐁𝐄. He is credited for the discovery of proton. And please mark my words. I'm not saying that he discovered proton. I'm saying that he is credited for discovery of proton. For discovery of proton. Now what does it mean? Why I am saying that he is credited for discovery but not that he discovered? You'll understand. Basically he did an experiment once again on gas discharge tube, and in certain circumstances Mr. Goldstein found that some particles were coming out from the anode, some particles were coming out from the anode, right? And these stream of particles were called anode rays, right, students? As the stream of particles from cathode were called cathode rays, stream of particles coming out from anode were called anode rays or canal rays. You understand? And it was found that the particles which were coming out from here, they were positively charged. They were positively charged, students. Okay. And also, their masses were different. Different masses. You understand the point? See, lot of small particles were coming out. All of them had positive charge. But some had more mass, some had less mass. Their masses were different, students. Their masses were different. So we can write this down. Anode rays were emitted from anode. which had positively charged particles of different masses. So see, actually the particle of smallest mass, particle of least mass, was actually one proton, students, right? So the particle of least mass which was coming out was actually one proton, and particles of larger mass were actually bundles of protons, like you understand. So from here single protons were coming out, and bundles of protons were coming out. For example, bundle of 2 protons, bundle of 3 protons or 4 protons, bundle of 5, 6 or many protons, right? So you can understand why particles of different masses were coming out. So basically the least mass particle was a single proton, and the heavier particles were collection of protons. So see, this thing was noticed by Goldstein. What? That anode rays were emitted from a node which had positively charged particles of different masses. This thing was discovery of Goldstein. But later different scientists analyzed this experiment even deeper, and they came up with this conclusion that the least mass particle is actually a proton, and the heavier particles are actually bundle of protons. And it was then when proton was discovered. So now you can understand why I am saying that Goldstein is credited for discovery of proton, because he was not the only person who contributed for the discovery of proton. There were other scientists who actually gave this idea, and proton was finally discovered. Got the point? Fine, students. Now let us talk about discovery of neutrons. So neutrons were discovered by this gentleman who is called James Chadwick in 1932, students. Right? And let me tell you one important thing, students, that hydrogen atom has no neutrons, Rest all atoms have neutrons. So students, hydrogen is an element. You must be knowing about it by now. Hydrogen is a very simple element, and its atom has no neutrons. It has only electrons and protons, right? So we have seen that atoms can have 3 types of subatomic particles: electrons, protons and neutrons. But in hydrogen atom, students, there are no neutrons. There are only electrons and protons. Very important point, students, you must remember. In rest of all the atoms, neutrons are there. So basically in rest of all the atoms, neutrons, electrons and protons all are present. You understand? So now, students, we have seen about the discovery of all the 3 subatomic particles. So let me remind you that protons were discovered in 1886. Electrons were discovered in 1897. So protons were discovered the first, then electrons were discovered, and finally neutrons were discovered at the last in 1932. Right, students? So it will be good if you can remember these dates. Sometimes they can be asked in your exams. Okay. So sequence is very important. That first proton was discovered, then electron was discovered, and at the end, most importantly, that at the end neutron was discovered.